Hi and welcome to Maths class. Today we are looking at linear graphs, and what we're really going to be doing is going over some key skills that you would have seen last year in year 8 and possibly even in year 7. So there shouldn't be anything really new here, but it's always really good to revisit these things because sometimes we don't quite understand the first time round. So first of all, a reintroduction to the Cartesian plane. So the Cartesian plane is a way of locating points in space, on a plane, all right? So remember that the word plane just means a two-dimensional space. That's what plane means. So for example, a piece of paper is a plane, P-L-A-N-E, not the flying kind. So how do I identify points? If there's a point there, first I start at the origin, and I see how far I go to the right. I went 4 to the right. And then I see how far I go up. I went 2 up. Now both of these are positive, so this particular point is in quadrant 1. The word quadrant, of course, is linked to the word quarter because I've divided my plane into quarters. So let's look at another example. If I have this point down here, let's say, how will I identify where that is? Well, I start at the origin. The origin is this point here, which is where the x and the y axes cross. How far to the left did I go? I went -3. So my first value, my x value, is -3. I know it's negative because I went left. And then I go down, which is also negative. And I went also to, it's not marked here, but it's in between -2 and -4, down to -3. So that's this point here. Now, my quadrants are 1, 2, 3, and 4. So if I ask you whether the point 4, which quadrant the point 4, 2 is in, you would say quadrant 1. And if I asked you where the point -2, +3 is, well, to find the point, I go to the left -2, and then I go up 3, and that brings me to the point -2, 3, and that's clearly in quadrant 2. Okay, so that's quadrants and plotting points. This is all revision, quite definitely. So let's go to the next page. Our first skill is plotting points, and I'm doing this for a very easy example, y = x - 3. You would more likely have a coefficient in front of the x, but let's just get started with this. So I've got my axis set out here, ready for me to sketch, and what I need in order to plot is I need a table of values. Now you might be given the table of values, but if you're given the rule, first you have to fill in the table of values, and we typically go from x is -3 to 3. Now here you've got the numbers listed, but what you might also see is something like this, which says I want -3 to be less than or equal to x to be less than or equal to 3. That's just another way of saying for the numbers from -3 to 3, okay? So all we do is we do a substitution. I put the first x value in here into the equation, and then I see what y value I'll get. Let's start with x is -3. -3 minus 3 is going to give me -6. Then go to -2. -2 minus 3 is going to give me -5. -1, put it in here, minus 3 is going to give me -4. When x is 0, I get 0 minus 3, which is -3. 1 minus 3 is going to give me -2. 2 minus 3 will give me -1, and 3 minus 3 will give me 0. Now the other thing that's worth noticing is that these all increase by or decrease by the same amount. In this case, they're all increasing by 1. That's +1, that's +1, that's +1. Now, it's not always by 1, but it'll always be the same amount as long as x is always going up by 1. X goes up by 1 here. And when I do it like this, -3, -2, -1, 0, 1, 2, 3. They're all increasing by 1. So I can see that my y values are also all increasing by 1. Now that's just a way I can check. The second way I can check is when I plot my points. This is a linear equation because y has a power of 1. This is y to the power of 1, and x has a power of 1. There's no dividing by x or dividing by y. And there's no squaring or anything like that, or square rooting. So this is definitely linear, which means I expect a straight line. So when I graph it, if I don't get a straight line, or if I've got one point that looks like it's not in the pattern, then I'll notice it. Okay, now this is how I plot my points. When x is -3, I get y is -6. That's the first. This is called a coordinate pair here. So I go to -3 and -6 is off. So I'm not going to draw it on because it might be slightly out. -2, -5, and if that happens, that's fine. You don't need to draw it. Now I don't need to label these points. I just need to clearly mark them with a point. -1, -4. So I start at the origin, I go left 1 and down 4, and that brings me to this point here. 0, -3, so I start at the origin and I stay there, but then I go down -3. So I don't move horizontally because my x value is 0, but I do move down because my y value is -3. 1, -2, so I start at the origin, I go to the right 1 and then down 2 because y is -2, and then 2, -1, and finally 3, 0. Then I grab my ruler. Always grab a ruler. I've got a straight line tool here that I can use, and I'm going to connect my points with a line. And I don't stop. I actually can keep going. It's being a bit fussy. It doesn't want to sit. That'll have to do. It doesn't want to sit straight on the line. But there is my straight line. And then what I'll do is I will label it with its equation. Y equals x minus 3. So an important thing that I said there is that I don't stop here. This line, I've plotted these points, but that doesn't mean it stops at these points. The line keeps going forever, actually. So I don't need to stop there. So that is plotting. Plotting is when I make a table of values. All right? So if you ever see the question saying plot, then you need a table of values, and you might need to draw it yourself. All right, let's keep going. Now we're going to look at a quicker way to draw a line, because actually a straight line is defined by 2 points. In fact, let's just go back to this example. As soon as I had any 2 points, like these 2 points here, for example, I could have drawn a straight line through them and the line would have been accurate. It doesn't matter which 2 points I choose. So what we can do is we can draw a line. This is called sketching, not plotting. All right, so now I haven't written this here, but I'll just jot it down up here, the word sketch. If you're asked to sketch, then we just want the line and we don't need a table of values. So 2 points is enough because it's a straight line. We know it's a straight line because of this equation, y equals 3x plus 2. We're going to explore more about how we know this is linear later in the course. So I need to plot 2 points, any 2 points. So I need to choose 2 x values. I'm going to choose, well, I reckon x is 1 is nice and easy to substitute. So if I let x equal 1, I get y equals 3 times 1 plus 2, which gives me 3 plus 2, which is 5. So my first coordinate pair is going to be 1, 5. Okay, I can now choose any other value for x. Let x equal, I'm going to choose, just to be random, -2. Not the easiest thing in the world, but that doesn't matter. I can choose any one that I want. When x is -2, I get y equals 3 times -2 plus 2. Now the 3 times negative 2 is negative 6 plus 2, which is going to give me a grand total of negative 4. So my second point is negative 2, negative 4. Now the important thing here is that the answer of y equals 5 that I got in the first one, that goes with my x value of 1. And the answer of y equals negative 4 goes with my x value of negative 2. If I drew a little table of values, it would have looked like this, only neater. X and y. X is 1, y is 5. X is negative 2, y is negative 4. The only thing I don't have here is when I plot and I've got a pattern, I can check that I'm going up by the same amount each time. I can't do that here because I've only got one pair, I've got 2 points, which is one pair. All right, let's plot them. 1, 5, so I start at the origin, I go to the right one and up 5 and mark my point. I don't need to label it. Negative 2, negative 4, go down to there. And then I'm going to join them with a straight line. But this is going to be tricky for me because I want my line to go a little bit beyond, oops, I chose the wrong tool. Hang on. Okay, I want to go a little bit beyond. So there we go. Keep going. Oh, it's stuck. Try again. Here we go. Beautiful. Oh, it moved at the last minute. That'll do. That will have to do. There is my line. With a ruler, always. Always with a ruler. I don't care about your table of values being wonky. Your lines and your axes have to be wonky. Now, while we're on this point, let's just look at a few things about this graph. If I'm in a test and I want to get good marks on the graph, what do I have to do? I have to label my x and y axes with x and y. That's if I drew the axes myself. I have to label these guys. I don't have to label every one, but I have to label enough of them so that I know what the scale is. And in this case, the scale is telling me that 1 square horizontally, that equals 1, and 1 square vertically, that also equals 1. So these numbers here help me to do that, and they also help me when I'm sketching, so I can easily find negative 2, negative 4. Notice that the y numbers are all on the left of the y-axis, and the x numbers are all below the x-axis when you're sketching. Also, my line is straight. I used a ruler. Straight line. And my working is shown. For a question like this, I would need to show my working, certainly at year 9. Probably not past year 9 because I would expect you to do that in your head. But in year 9, you'd need to show your working. All right. So far, we've learnt 2 key skills. Well, we revised the skill of just plotting points. We learnt how to plot from a rule using a table of values. And now we learnt to sketch by just drawing 2 points. Our last skill for today is to check if a point is on a line. So in this example, we are given an equation, and in this case, the line is y equals 2x minus 1. And we're given 2 points, and we need to check if they're on the line. Now, I've got the line drawn there so I can show you what I mean by on the line. But normally when you get this question, you won't have a graph. You'll just have the equation and the points. So we're using this just for explaining today. So first of all, let's have a look at these 2 points. 3, 5, where does that sit? I go across from the origin to positive 3 and then up to positive 5. It's definitely on the line. 3, 5. Let's look at my second point, negative 2, 3. We go to the left to negative 2 and down to and up to 3. I got tricked then. There it is. Negative 2, 3. This point does not sit on the line, okay? Now, if I had the graph, that would be enough to help me decide. But if I didn't have the graph, how would I decide? So here's the information you need. If a point is on the line, then substituting into the equation, will make the equation true. So what do I substitute? Well, the first value in my coordinate pair is always x. The second value in my coordinate pair is always y. So I'm going to substitute in x equals 3 and y equals 5. And it should make this equation true. So let's have a look at it. 5 equals 2 times 3 minus 1, which gives me 5 equals 6 minus 1. 5 equals 5. Yes. Yes, this point is, oops, not yes. Yes, this point is on the line. Now, we're not expecting it to work for this one because we can see that the point is not on the line. But this is how we know using the equation instead of using the graph. Again, I'm going to substitute x is -2 and y is 3. I'll just draw a line there to help me show I'm on the next question. So y is 3. So 3 equals 2 times x is -2. Now notice how I use brackets instead of writing times. You could write 2 times -2. That's just a habit I've got. Minus 1. And let's see what we get. 3 on the left. 2 times -2 is -4 minus 1, which is -5 on the right and 3 on the left. No, this point is not on the line. So what we're really trying to understand here is the idea that a line is an infinite set of number pairs, okay? Here is, in fact, for x is -2, I should have, whoops, -2, -5. This is called a coordinate pair. And it's always xy. X is first, y is second in alphabetical order. And remember that my x's go across horizontally and my y's go up and down. So I've got my coordinate pair here. That's one point on the line. A straight line is an infinite set of points that have to follow this rule. The equation really is a rule for a line. So the point will be on the line if it follows the rule. If it doesn't follow the rule, the point is not going to be on the line. So that's the end of our video. It's really a revision lesson on straight line graphs. And before we go, I've got one more thing to show you. Now, this is not to scare you, but I just want to show you what happens if you leave your new technology that helps you to draw pictures on your computer unattended. There, yes, that's what I found on my PowerPoint presentation. So there you go. We'll finish on that note. I'll see you next time.